Hello? Okay. Good afternoon, everyone. Are you guys ready for lunch or for a session? All right, I know this is kind of unfortunate timing, but hopefully it's going to be interesting for you guys. All right, my name is Igor Stanko, and I am part of the parallel data warehousing team. Question for you guys. How many people have heard of parallel data warehouse? Okay, few. How many people actually work with PDW? Had actually hands-on experience? Okay. All right, so hopefully we'll cover some of that. I will address probably both points today. A little bit about myself. As I mentioned, I'm part of the PDW team. I'm part of the program management team, and specifically I'm responsible for a query processing component. So basically, optimization, how do you figure out what's the best and optimal plan to execute when you start executing a particular query. I've been involved with a couple of projects. I think lately been involved with the column store technology. How many people have heard of column store technology that SQL Server has? Okay, so we'll touch upon a little bit about that. But yeah, so main focus for myself is around query processing. All right, so before we go into the details, logistics-wise, we are a small group. Please feel free to pose a question at any point in time. Just stop me and say if you have any questions, and we'll address it. We should have enough time also at the end to have some specific Q&A time for ourselves. All right, so what we're going to cover, just a little bit of the industry trends. Hopefully this is going to be known to all of you guys. And then we'll talk about how PDW addresses the need. And then we'll talk a little bit about what's new in PDW, since there is lots of people who don't have that much exposure to PDW itself. So we'll talk a little bit about that. And at the end, there is going to be a bunch of demos. This session is about how to actually connect BI tools to PDW. So we'll actually do a bunch of demos, and I'm going to demonstrate. And hopefully, at the end, you'll say, "Okay, Igor, we get it. We know how this works." Okay. All right, a little bit about the industry trends. So hopefully no surprise there. I've spent pretty much all my career in data warehousing space. I've had probably 15 years of data warehousing experience. And every year, I've heard data warehousing, much more data is actually available. We need to actually store more and more data within data warehousing solutions. And when I built first data warehouse, it was 1 terabyte data warehouse, and at that time it was very large data warehouse. And I think most of you would agree today that's, I would say, small on the smaller size. Due to the expansion of the data, there is basically, it puts a little bit more pressure on the technology and what do you need to do technology-wise to address the need. You see a quote from Jim Kobilius from the Forrester Research. And we truly kind of share his view too, basically where he says that pretty much the whole data warehousing space has shifted towards the appliances, as well as that you require an MPP solution in order to address the requirements, scalability requirements of your data warehousing solution. All right, another one, and hopefully no news here too, is the dimension around the big data, right? How many people actually are considering big data solutions today? Okay. Clearly, social networks, as well as the mobile space, sensors and whatnot, basically just puts tremendous actually pressure on the data sizes and how do you actually store this information within the environment, your environment. I put the quote here from Gartner just because I think it's interesting, that it says that existing data warehousing solutions, if they don't pay attention to the big data, basically they'll get replaced. We'll talk a little bit about how PDW addresses the need, and then there's going to be a couple of slides in this regards too. But again, we also share our view with Gartner too on this. So it's not, in our view, it's not relational versus non-relational. Everything is going to go to Hadoop or everything is going to go to relational. We actually believe in the unification of the two platforms and offering unified view of all the data within the enterprise. All right, so a little bit about the SQL Server or parallel data warehouse. So what is parallel data warehouse? All right, so first of all, Parallel Data Warehouse is a SQL server, right? I don't want you to think that Parallel Data Warehouse is a different product. It's actually a SQL Server database, right? The only difference from SQL Server database is that actually we are a scale-out solution, meaning that SQL Server traditionally has been installed within the one box, if you will. So what Parallel Data Warehouse does is actually scales out that solution, and now we can actually have approximately from 2 to 50 or 60 SQL Server nodes running within the same appliance, addressing, basically crunching the data at runtime. It's standard-based, so we speak TSQL language. So the way you interact with an appliance is just you would interact with the ordinary SQL Server database, so TSQL language. And we feel it's very important for us to actually address that space or that need. And hopefully that's going to come out from the demos once we start talking about that. Flexibility. So today we offer 2 vendor choices. So you can either buy Dell or HP, and depending on many organizations standardize on one vendor versus another one. We don't have preferences. We actually work with both vendors, and so you can actually order any of these. We are a standards-based solution, meaning that we use commodity hardware. There is no special hardware in our solution whatsoever. Again, very important because some of our competitors actually address the space or need differently. And cost-effective. I think when we announced the Parallel Data Warehouse as a first release, we were one of the lowest solutions on the market, lowest as far as price per terabyte. And we are actually taking these to the next level too. So we'll talk about that too. But something to take home too. All right. So since not many people understand kind of the Parallel Data Warehouse and MPP solutions, let's spend one slide just describing how this actually works and what are different components and how does the appliance look like. All right, so there is a client application, and that client application actually connects with the appliance. Within the appliance, we have obviously hardware components, as well as there is software components that are running. Don't pay too much attention about different node types because we changed things a little bit in our latest version of the product, and we'll talk about it. But just from the flow perspective, there is a control node who is responsible for orchestrating how do we actually take user query that you submit to an appliance, and how do we actually send this now query to all different nodes that we have in the system. Right? So we spoke about the query processing. So that's basically where PDW lives. Okay, and then once we determine what's the best optimal plan to actually execute at runtime, we actually send those queries to compute nodes, which are actually nothing but the ordinary SQL Server SMP nodes, right? And I would say dumb in a sense that they are not aware that there is like 50 of them or 60 of them working together on the pieces of a problem. But basically, they're interconnected with a fiber channel or InfiniBand for the fast communication between the nodes. Depending on the query that you submit to an appliance, sometimes a whole query can be actually executed just within a single node, independent from all other nodes that exist in the system. Or sometimes there is a need to actually move the data within the appliance so you can actually address the query and deliver the answer correctly, right? We have a component that's called data movement service that is actually responsible for moving the data within the appliance between compute nodes or delivering the data all the way to the client application. All right. Let's take an example. How does this actually work in real time? So let's assume that we have appliance. So think of this as a unit of one single appliance. So Sales Web is actually my SMP node, right? I have 2 nodes here, and I have a Parallel Data Warehouse engine that lives on a control node. So what happens? So when I send select crown star from Sales Web, the first thing is basically PDW engine takes this request and says, okay, now I understand what you're trying to do. There is authorization, there is authentication, all things that happen in kind of you would expect from the traditional relational database. But I think there is some specific things that PDW does in order to actually resolve the query. And so we'll talk a little bit about that. So first thing that we do is basically we create a temporary object. So there is a temporary table being created. And then we split the query and say, send the query to each node independent from each other and say, give me a count star based on the data that you have on that particular node. Okay? So once the query is basically executed on the node, the data, then we spoke about the data movement service. Data movement service actually takes the data and moves it into the temporary table that we created previously. There is actually one step that's missing here. Anyone can tell me what's wrong with the picture? Is there anything else we need to do after we collect the data from each node? So remember that we selected count star. We need to now actually sum it up. So we can actually, since we get all the data from each compute node, now we need to sum it up and then deliver the result to the user or to the client application. One thing to keep in mind here is that this happens completely transparent to the application. Okay? PDW as an engine is responsible for orchestrating and how the data needs to be actually composed together. Client application is not aware of any of this. Okay? This is kind of internal to the client application. All right, let's talk about what's new. So we announced first version of the product 10.10.10, so 2010. And a few months ago, actually 2 months ago, we announced second iteration of the product. And so when we started looking into what do we want to do with this appliance, what is the functionality that we need? I think there is 3 major areas that we wanted to focus on. One, we wanted to bring the cost down. Right? We spoke about lowest price per terabyte. We wanted to actually make that even lower. So that's one of the goals. 2, SQL Server 2012 announced column store technology. So obviously, since we are focusing, PDW is focusing on the data warehousing use cases, we always knew that we wanted to consume column store technology. So we wanted to embrace this and offer basically order of magnitude performance improvements for data warehousing use cases and for our appliance and for the user. And 3, we spoke about the big data and integration. So in our view, basically, it's critical that we offer unified view as well as kind of the T-SQL interface, if you will, to the big data. So what's the problem with big data? It's big data, everyone talks about the benefits. You can store humongous amounts of data. You can have huge clusters. However, what is the problem? How do we integrate BI tools actually with the big data, right? Very few BI tools on the market actually offer direct integration with Hadoop. And in our view, basically, what we are offering, and we'll talk a little bit about that, is we offer that T-SQL interface that you are familiar with from the SQL Server. We offer that on top of Hadoop data. Okay. There is more kind of when we start thinking about the release, we start thinking about the benefits, what are the themes, but these 3 kind of groups are the major innovation that happened within the V2 timeframe. So I have 2 slides, I think, for each of these groups, and we'll talk a little bit more about that. All right, so remember that I spoke about the control node, compute node. Actually, that's changed completely in the V2 timeframe, right? In our new or next iteration of the product, we actually think of it as a set of nodes, and each node can play a node of a control or compute node, right? It's a dumb hardware, so it doesn't know basically what it's supposed to execute. There is a software that runs on top of these hardware components, and it actually orchestrates the workload that needs to happen. All right, a little bit about the software and hardware components that we have within the system. So first of all, what we are saying here is our smallest footprint appliance. It's a quarter rack appliance, so there is 2 compute nodes, if you will, and then there is one host one which serves as a control node to start with. But as I said, control node can actually move anywhere within the appliance. Another thing, and I have one more slide that talks a little bit about that. Another thing that we changed is previously we used to have a SAN storage, which is typically kind of pricier on the pricier side. So we removed that with actually JBODs and ultimately drove the price for appliance drastically. There is directly attached storage to all the compute nodes, and the compute nodes have direct access to JBOD. We run, all the hosts actually run Windows 2012, okay? And one thing that we did embrace in V2 timeframe is actually virtualization. Now, workload is actually run within the virtual machine. So a compute node or SQL server that runs on the compute node is actually nothing but the VM. The control node that contains the PDW component or the workload component is nothing but the VM, so it runs within the VM. And there is a couple of things that are nice about it. One is basically if you need to fail over from any node to another node, is all you need to do is basically start new VM and things just work. But also going forward, it's going to allow us to offer like online patching and all this kind of online functionality that you would expect from the appliance. All right. There is kind of other components. Yeah, I'll let you read a little bit of slide. I think main takeaway from this is that there is VM, so we completely embrace virtualization, and there is direct attached storage, JBOD, which drives the price down compared to what we used to have. All right, so here is a diagram. Again, it's high-level diagram, but how things look like in V1 timeframe. So if you look, kind of, this is one data rack. There is a 10-node appliance. There is control node, which was a separate, basically, hardware. Contrast that with the picture that we showed previously. So there was a high redundancy there, right? There is a management node, again, redundancy there. Landing zone that was used for loading the data into the appliance. But the point is, there was much more hardware than what we have today. Not only that we reduced the hardware, we've actually increased the density, if you will. So there is now more cores, there is more memory available in the system, there is more storage space available in the system. Now we scale all the way to a couple of petabytes of data, including once you actually compress the data, it actually goes to 5 to 6 or more terabytes of data, user data, that can be stored within the appliance, just one rack. We support also multi-rack appliances, so you can go all the way to 4 or 5 racks. So sizable amounts of data can be actually stored within the appliance. There is some pricing here. I'm not going to go too much details in this regard. I think key point here is that we drove the price per terabyte probably about 70% down from our initial release. And it's all coming basically from storage as well as the reduction in the hardware components that run within the appliance. We spoke about flexibility in our kind of one of the first slides that I mentioned when I started the presentation. We have a variety of appliance sizes. So depending on what your needs are, you can actually start with as low as a quarter of rack, which is 2 compute nodes, and scale all the way to a couple of racks. Appliances. There is HP, there is Dell. Again, this speaks for itself. The point is basically that we allow you to actually start small and then you scale as needed. You can add racks or add units as you grow and as the business grows. There is no need to buy kind of immediately a couple of racks, but you can actually purchase and buy as you go. All right, so column store. As I mentioned, so we always wanted to, because we focus on the data warehousing use cases, we always wanted to embrace column store technology. However, when we started looking into 2012 version of column store, we realized that it actually didn't quite well fit into an appliance model. There is a couple of things basically that we didn't like from the initial release, if you will. One, basically, it was not updatable. So for people who are familiar with the column store technology, initial version was not updatable. So we actually fixed that. And this version of column store, now actually we have updatable column store. There is going to be a separate talk that I'm going to give next Friday or this Friday. It's going to focus, deeply on the column store technology, kind of how we are innovating in that area. I'm not going to spend too much time here, but I want you basically to at least have high-level understanding about the column store technology, what that is. So now column stores are updatable. We broadened the data type support that can be used and column stores can be created. We created what's called a cluster column store index. So initial version of column store technology was a non-cluster column store technology. What that means is basically you were required to have your base tables, and then you create a secondary index, which was a column store, right, index. And by doing that, you actually get, performance and reduction and compression, if you will, of the data by having the secondary indexes. However, your base table still needs to be there, right? With the introduction of cluster column store indexes, we removed that requirement. Now, to start with, you can immediately insert or put your data as a column store, and there is no need for the row store technology anymore, right? One, clearly there is a reduction in space because there is no need for row store and column store to coexist together. And two, you get basically all the good benefits of the column store technology that you would expect. How many people have heard of batch processing? All right, so there is actually a big innovation in the query processing and how do you process the data at runtime within the SQL Server. So traditionally what SQL Server does, and for people who are familiar with the query execution in SQL Server, there is a phase where you go authenticate, kind of security phase, but there is a phase where you go through the optimization phase. And that's where SQL Server goes and says, what's the best and optimal way to actually execute a particular query? And typically, once you determine what's the best plan, typically it's called like a tree, operator tree, you actually start executing the query. But the way the execution happens is basically you go to your data and process row by row, right? So when we looked into the column store and when we looked into the query processing, we asked, can we do something better? And we introduced what's called a batch processing. So rather than doing operations on a row by row basis, or doing basically joins on a row by row basis, we actually operate on a batch of rows. So think of it, we bring 1,000 records in memory and then do all the operations on 1,000 records. Clearly there is CPU savings by moving the batch of rows to the operator trees, but other than that there is huge performance benefit from that. So they were, in the initial version of column store, not all the operators were implemented using the batch processing. So now we actually extended as far as what kind of operators can be executed within the batch execution. Just to give an example, inner join used to be implemented as a batch processing. However, if you try to do outer join, it wasn't. So we basically patched those gaps too. So now there is a wide range of scenarios actually that benefit from column store as well as the batch processing, if you will. One thing that I want to highlight here is that, yes, we are talking about PDW here, but I think in general, the fact that we actually improved the column store technology, that we are offering the cluster column store indexes, we are actually recommending customers that we use column store indexes as a primary storage engine. Specifically, if you're addressing the data warehousing use cases, you definitely want to use column store technology. Here is just an example syntax. Again, a standard DDL that you would expect from a SQL Server with an extension that says create now table with a cluster column store index. All right, so I spoke about the performance benefits, right? The graph there basically compares performance benefits when we took PDW without the column store and then PDW with column store, and we ran TPCDS on top of that, and you see basically the results vary. There is no kind of silver bullet that says every single query is going to improve by order of magnitude, but majority of queries kind of fall into the 5x to 10x kind of the range, and that's kind of typical what we would expect to see on an average. So where is this performance coming from? One, column store improves the I/O, right? So rather than scanning the whole row, you are scanning only the data that is required for the query. Two, there is actually compression, better compression compared to row store, because now you're compressing within the same data domain, so you can actually compress better. So there is a smaller footprint on the disk. Again, yet another I/O benefit. And we spoke about the batch processing. Also, batch processing kicks in. Again, more information is coming. If you guys are interested, on Friday we have a dedicated session towards the column store, and we'll go very deep into the technology. All right, we spoke about the big data. So if you look into where the market is today, majority of the solutions are implementing the data warehousing in the relational data stores, right? And that's pretty much, I would say, 90–95% of the market today. However, there is this trend where you need to do something with the big data and how to actually embrace the big data technology, because. So let me step back. I did mention basically one of the benefits of the big data is that you can actually store lots of data within the Hadoop, right, and HDFS. The secondary benefit of HDFS is, anyone? Redundancy, right? You get built-in redundancy. You don't need to worry about it, right? In general, if you want to make your data reliable, you need to either replicate the data into another data center or whatnot, or you need to basically implement the disaster recovery, if you will. With Hadoop, that's all built in, right? You don't need to worry about it. However, we spoke about there is no actually easy access to the data, right? So yes, you can write MapReduce jobs, and typically you need a programmer basically to go and write your Java application that actually accesses this data that's now stored in the HDFS. But there is no easy way to actually, other than you coding, there is no easy way to get the data out. So what we've introduced in V2 timeframe is what we call a polybase. So poly comes from, it means multi, right? So the idea is that we are not only a relational store, we are not only a non-relational store, but we are actually talking about the bridging the two and exposing these both worlds, non-relational and relational, through a single unified interface. Okay. Obviously, clear benefit is that now you can attach any application or BI tool on top of the appliance, if you will, irrespective where the data lives. You can actually query it using standard SQL language. All right, so let's talk a little bit about the solution and how we do it. Actually, let me run this build completely. All right, so assumption here is that you already have your Hadoop cluster and you have relational data here. So all you need to do is basically you need to create what we call external table. Right, so within the PDW, there is data that we directly manage, meaning that you can actually update it directly, and we have full control over the data set. Hadoop is an external data source to us, right? And we introduced what's called concept of external table, right? The idea is that you create a table-like object inside the appliance, but now that table points to a folder inside the Hadoop or inside the HDFS, okay? So once you see basically there is location, that's actually your physical location where Hadoop cluster is where your folder is, where the data is going to be pulled from. So once you define your external table, this gets stored together with all our catalog tables that we directly manage, right? So then once it's stored within the catalog tables, any query, any operation that comes on top of the regular table, if you will, automatically works with this external table too. And we'll go through the demo, and hopefully it's going to be a little bit clearer there. So what happens is actually when you run a query, so say select top 10 or from clickstream, which is external table from on the top of the Hadoop data. So what happens is actually there is a component that's called HDFS bridge within the appliance. So what that component does is actually, we spoke about the data movement service, right, that moves the data within the appliance. So we extended that data movement service so it actually can talk to Hadoop now natively. But it's not just talks to Hadoop, actually it talks to Hadoop in parallel, right? We want to embrace the parallelism or all the nodes that we have within the appliance, as well as the parallelism of the Hadoop and the HDFS in general. And so we talk to Hadoop in parallel. We push down the queries as much as possible to Hadoop, and then bring the data sets back to PDW. And now you can actually store the data together with the other PDW objects or the other relational data sets, or you can actually do the join between the relational sets and non-relational data too. Pretty powerful. Okay, so there is also another concept. So for people who are familiar with parallel data warehouse, there is a CTAS operation. And CTAS is basically think of it as a materialized view, right? It allows one to actually create a temporary table, or sorry, a permanent table, either temporary or permanent table, and store the data inside the appliance as a selection from other data sets. So you can say create table as select, and then that select can be selection from other tables. These CTAs actually works also on top of the Hadoop data sets or external table too. So you can actually now bring the data from Hadoop into relational world, and the primary use case there is that some people, and I've spoke to a couple of customers, some people actually use Hadoop as an archival engine, if you will. So they store all the data inside Hadoop because it's cheap, and then only the active data sets are being pulled into the PDW and then joined together with other PDW data sets. And that's the primary use case behind here, is that not always you want to go to basically your Hadoop because not all the data is usable, and you want to identify the data that is usable. You bring it into PDW, and now you work with this data set like just any other object in PDW. All right, so but we don't have just that read-only, if you will, access to from Hadoop, right, into PDW. We have actually the bidirectional interface with Hadoop. So you can actually go now from PDW to Hadoop. And the primary use case here is that, we spoke about archival use case. So, at some point, you keep loading your data warehouse. You don't need all the data sets inside the data warehouse. You want to offload your data warehouse and move the data into Hadoop and store it permanently, if you will. If business requires it at some point, you can also kind of bring it back. But the idea is basically that we merge or we think of Hadoop as kind of a logical extension of a relational data source or PDW, if you will. Again, there is a notion of, we spoke about create external table. There is a notion of create external table as select. Right? There is CTAS, which is going from Hadoop into PDW. There is the vice versa, CETAS, going from PDW to Hadoop. Again, all this happens in parallel. If it doesn't happen in parallel, there's really little value that we provide. And you want this basically to be executed in parallel for performance reasons. All right, so reiterating kind of the benefits of PDW. One, you can actually work with both relational and non-relational data store, right? You as a user don't need to worry. If you have a DBA or if you are DBA, you can actually set up the environment, and now client application doesn't need to worry about where the data resides. It worries about what is needed for that particular application. We do the rest, okay? We allow you to actually start small and scale all the way to petabytes of data as you need, or you can start from petabytes and then scale even further, depending on where you are just within your environment. We offer you known T-SQL interface, right? Just you interact with any SQL server, that's how you interact with PDW, as well as Hadoop. Very, very important. And due to column store technology, we allow you to actually store more data inside the appliance because now we compress data more. Okay? We've been seeing kind of from customers, we've been seeing probably about 5 to 10x compression on the data. So think about it. You'd have 1 terabyte of data, that user data. You load it into appliance, suddenly becomes 10 times less. Pretty powerful. All right, let's talk a little bit about, I think this is going to be one slide that talks about the BI. And hopefully the takeaways is going to be, and hopefully by now it's kind of clear how do we integrate with BI solutions. You connect to PDW just like with any other SQL Server instance, right? From the application standpoint, it doesn't know that now there is all these nodes that are running within the appliance and the data is being moved within the appliance. Application or BI tool is not even aware of that. It connects to PDW as a SQL Server data source. It submits a statement like eat food to SQL Server, and then we do the rest. Okay? And we'll do a bunch of demos here. I think I have 4 or 5 kind of different tools, and we'll go through that, and hopefully it's going to be obvious what I mean. You connect to PDW just like with any other SQL data source. Sorry, SQL Server data source. As far as the client drivers, we support both versions, either Snack 10 or Snack 11. One question: so how many people actually move to SQL Server 2012 version of BI toolset. View. So should I assume the rest is still with 2008? Okay. So both flavors are possible. It's your choice wherever you are in the upgrade path. Both flavors are possible. As far as the Microsoft tools, pretty much any Microsoft tool, BI tool, name it, SSAS, Power Pivot, Power View, Excel, Data Explorer. How many people actually had exposure to Data Explorer? We'll do the demo, but how many people have seen Data Explorer in action? It's pretty powerful. Report Builder, 2 or 3. So pretty much any Microsoft tool just works with PDW out of the box. Third-party tools, pretty much same thing, right? So business objects, Cognos, Tableau, ClickView. I have a demo. Hopefully we'll be able to do it, and time is going to allow us. I have a demo for Tableau and ClickView, but similar experiences for any other third-party technology that's out there. For MicroStrategy, we have a special adapter. So this is a little bit different story. That's why I wanted to have it separate. It's a little bit different story because MicroStrategy already announced their 9.3.1 version of the product. So they already GA with that. So we need to do something special with them. So there is actually an adapter that they built that connects to PDW. So if you're using MicroStrategy and you want to connect to PDW, you need to contact MicroStrategy, and there is a tech article. I forgot. There is basically an article that you can go and instructs how you can actually download this adapter. But if you're using MicroStrategy, just connect MicroStrategy, and they'll provide the solution for you, or the adapter rather, for you. Any questions so far? All right. So. Demos. I think, as I mentioned, with probably 4 or 5 demos, we'll switch into that. But before we go into the demo, let me provide you a little bit provide more info about the setup and what is that we have around the data. So first, I have what we call like a very, very small PDW machine, which we call it a SQL pod, which is just one node PDW machine. Not something that you can buy. That's for internal purposes. But it's very, very small, and it's in US, so some communication probably it's not going to go as fast as we would like. But I just want to throw it out there so you guys know that. I have 2 sets of tables, 2 sets of data. One is basically PDW managed data sets, and there is, I think, product and reseller sales data that is stored inside the PDW itself. And then I have one table that's internet sales that's stored inside the HD Insights, so Hadoop. Okay, and the goal of the whole demo is basically how do you connect the BI tool to PDW. Okay, let's do the demo. Let me switch screens. See if that works. All right. All right. So what I have here is data tools. So SQL Server announced basically data tools 2012 version of the product, and again, PDW works with these data tools just like SQL Server. So what I have there is basically PDW machine. What I'm using, basically, remember that I was talking about 2 sets of tables. You see that there is DIM product and factory sales. Those are the PDW managed objects. And then I have one external table that points to HD Insights, Hadoop. Let's just do view code here. So here is the DDL that I used when I created basically this object. I just want to open it up. So you see the location. It basically points to a folder where my HDFS files are. I didn't talk about it, but when you use that CE task object, since we are doing things in parallel, the way we're going to do this is basically we store multiple files inside the HDFS. Okay, each basically thread generates a file inside the HDFS. Okay. All right, let's do and just run a simple query. So you see that two PDW managed tables have a cluster column store. Right? We spoke about the cluster column technology, and the other one is basically represented as a heap object, but that's just external table to Hadoop. All right. All right, let's start simple. So let's use Excel. So I'm gonna, within Excel, I wanna bring PDW data. So how do I connect to PDW? So I go to data, I say from other sources, I say from SQL Server. Very important, from SQL Server. Okay, let me plug in my IP address. Provide username and password. I'm going to connect to my CCI database. I see my three objects. I'm going to connect dim product. I'm going to use dim product and bring that data set here, just because it's smaller data set. All right, so data came back. All right, so next thing I'm going to do, how many people have worked with Power Pivot? All right, good. All right. So what I'm going to do is basically now import PDW data inside the Power Pivot, and let's see how that works. I'm going to say manage. I'm going to say from database. What do I select? From SQL Server, right? All right, let's plug in the IP address, username, password. Let's choose our CCI database. Say next. All right. So we have our three tables. I'm going to bring all three of them. All right, so import is happening now, import in progress. So that's going to take a little bit longer just because of the location. So I think we have about 60,000 rows. Okay. So this is the interesting part. So I think the first two tables are something that you would expect, but this is the interesting part. Now we are talking to HDFS, right? Hadoop data. Notice that Power Pivot is not aware where the data is, right? It's talking to Hadoop, HD Insights. All right, almost done. Any questions so far? All right, we are done. All right, so next thing, I think this is more like a Power Pivot functionality, but we can actually manage the relationships. So you can define your relationship just you would with any other data sets. So let me find the product key. I'm going to join that to my reseller table. I'm going to join the product now with Hadoop data. Okay. And let's create a pivot table. So let's project English product name, and then we're gonna project sales amounts from internet sales as well as the other table. All right. So I'm not going to go into Power Pivot demo. Hopefully you guys experts better than I am in this technology. But the idea is that, again, completely transparent from the Power Pivot perspective. We manage the internals of talking to both Hadoop as well as the relational data sets. All right, I spoke about the Data Explorer. Let's see if I can do Data Explorer. Data Explorer from database, what do I select? I told you guys you were going to say, we get it. All right, from SQL Server, I provide my IP address. So let's take some other data set. So I have like multiple databases. So we can take, dim date. And bring the data set inside the. Now you can actually join this. Now it's basically Excel functionality, right? Now you can actually join this data set with other data sets that we created the model from, right? I can go into Power Pivot and say, model this and join this together with the other three tables that we previously modeled. Okay? So let's close this. Let's try Report Builder. How many people use Report Builder? Anyone? Okay. All right, so we're going to say new. Again, hopefully you guys are more versed on this than I am. So I'm going to provide the IP address. I'm going to say I'm going to provide my password. I'm going to select my database. It's going to ask me provide username and password. And here are my tables. Again, Hadoop and the relational. Do you guys want me to go through the whole demo and we can do report in it? Or yeah? Okay, let's do it. All right, let's project product key. And what did we use? We used the English name, right? English product name. Let's project that. We're gonna do product key here because we're gonna do the join. And let's do the same thing. We're gonna project sales amount, and we'll go to external table. Again, product key and sales amount. Okay, so let's define the aggregations. For this, we're gonna. Let me just make sure that it gets. So for sales amount, we're gonna do the sum. And where is the sales amount? We're gonna do the sum. Okay. So let's create the relationships. I have two joins. So I'm gonna connect product table with the factory seller, as well as the product with my external table. Let's define the join. Product key equals to product key. Same thing here. Okay, let's go to the next slide. All right, so here we're going to select product name, and then we're going to use sales amount, sales amounts. I'm not going to make it fancy. Let's try to execute. Data comes back. Again, aggregation of the data stored in Hadoop. I'm repeating it because it's pretty impressive. Okay. Let's see Tableau. So this is Microsoft toolset. I'm not going to demo every single Microsoft toolset, but let's try Tableau. All right, so within Tableau, anyone uses Tableau today? No? All right, so there is an option to connect to data. So when I choose an option, I say connect as SQL Server. Okay? Plug in the username and password. All right, so we connected. We're going to use our famous database, CCI database. And we see our three tables. Okay, let's actually do all three. So I'm going to select multiple table options, and let me add the other two tables. So I'm going to add reseller sales. Notice that it automatically took product key as a joining column. And I'm going to use my external table. Again, it identifies product key as a key column. We can preview results, but let's go and say we'll connect live. So there is multiple options within the Tableau that allows you to actually bring the data inside Tableau and then work with the cached data sets, or you can actually connect to data in the kind of the pass-through mode, if you will. I think we didn't talk about it, but since PDW allows you to actually store vast amounts of data, so hopefully you use this in a kind of roll-up mode. Basically, is that you don't want to move this data into the application, but you want to actually start pushing down the queries to PDW, so you can actually just bring the data that report requires. So that's this connect live option. Let's use English description. And then we're going to use sales amount. Let me find it. Drag and drop. And let's now external table, sales amount. Okay. So now within Tableau, you can actually use, their graphical tooling and whatnot. I'm not expert there, but the idea is simple. Again, external table, just like any other table, as a relational object, even though the data is stored inside the Hadoop, as well as combining that with the relational data, joining the two data sets and whatnot. So I have also quick click view. How many people want to see click view? All right, let's see. All right, so let me create new one. I'm going to say edit script. So here is basically a click view allows you to actually define where the data is coming from. I think click view, if I'm not mistaken, again, I'm not expert in this technology, but I don't think they have like a push down capabilities. They expect actually to bring the data inside their technology. But I've defined data source. So I'm going to connect to data source, which is just PDW. So basically establish the connectivity, and now we can go and say which tables do we want selected. Our three famous tables, external table and two tables, show up. So we can actually bring this data set, so we can browse the metadata. We can see the columns. Let's do the same thing for HD Insights. You see all the metadata just as any other table. You can preview the data. I'm not going to do that. So we're going to bring this data set. We're going to bring all the tables, including the HD Insights. All right. Say OK. Say OK. So then there is an option here to reload the data. So at this point, let me store this. Click view in a file. So at this point, basically now ClickView is going to communicate to PDW and start bringing the data inside their technology. Yes. Yeah. So the question is, if I have lots of data in PDW, and it's a generic question, right? Do I want to bring that all data sets inside my application, or do I work as remotely? No. So the idea is, as I mentioned, you want to push down the query and execute the query inside PDW, so you limit the result set that is being brought to the client application. In this case, I think ClickView just, at least I'm not aware of that functionality, so it brings the data sets inside. It wants to cache the data inside the ClickView. But in general, we would want to actually push the computation logic to PDW as much as possible. Then that way, basically, you gain the power of query the data where the data is, as well as of all the processing. If your PDW hopefully has sizable number of nodes, so you want to get that parallelism from PDW. All right, I guess it loaded. So let's see, table viewer, and here are our tables. Right? Now you can query this data set within the ClickView, just like an ordinary SQL Server or any other tables within the ClickView. Okay, so those are the demos that I had in mind. And that kind of concludes the session that I had in mind. So at this point, I would like to open it for Q&A. Yes.
Regarding testing or hands-on, is there a testing environment available for customers?
Yeah. So we have. I think. So the question is there a test environment? The simple answer is yes. So I'll give you a little bit longer answer too. So what we've seen customers do is basically, customers who have limited budget, they buy one appliance, and then they have different databases. They use basically test database, they deploy test database and production database, and so they manage it that way. We also have a test dev appliance, which is obviously cheaper than your real appliance, but you can buy dev test appliance too.
I assume there's no way just to install for Hyper-V installation.
Well, we have it. That's actually what I'm doing the demo from. However, we don't officially sell it, so it's not a product that we sell. But having said that, I think we also now, from V2, we have a quarter rack appliance, which is like 2 compute nodes. Hyper-V is just one, right? So it's one additional node, and you work with the real appliance. So we would actually encourage people to go with the quarter rack appliances to start with. Any other questions? Yes. Sorry, can you repeat the question? Oh, I see. So the question is basically, how does PDW fit with ETL tools? Fits nicely. So basically, we have ETL tools like Informatica. I think Cognos has an ETL tool. Business Objects has an ETL tool. So the way you work with PDW is, again, just an ordinary SQL server. I think there is a little bit differences around the target objects where you load the data to. So in that case, basically, we don't actually tell people to go and use like a traditional SQL Server tables. There is a special connector that registers within, let's say, Informatica. And once you register that connector, basically you can import PDW tables as metadata objects inside Informatica and use that as a target object. The rest of the flow is pretty much the same as you would have with SQL Server. So importing the metadata, if you use PDW as a source, you can import metadata from PDW just as SQL Server. You just we represent the tables normally. You can use PDW as a lookup table. You can import store procedures from PDW just an ordinary SQL, just like in ordinary SQL Server. So it's pretty much the same story. The only difference is basically that for target objects, we would like to have PDW connector. And the rationale is that SQL Server, BCP, uses basically BCP behind the scene, and that is single-threaded. And our bulk loader is actually multi-threaded application, or the client application. So we want to enable people to load data in parallel and very fast into the appliance. So it's a key. And that's the rationale behind building something that's specific to PDW. Good question. Any other questions? Going once? All right, that concludes the session. Thank you.